All right, so this problem was requested. It is from somewhere around page 128, I think it's 130, and it is problem number 33. So what I'm going to do is I'm going to go ahead and first read through this problem. Rachel pulls her 18 kilogram suitcase. That 18 kilograms, that's the mass. I wonder how heavy that is. Anyway, at a constant speed. Constant speed. That is interesting to me. So it's not accelerating. By pulling on the handle, that makes an angle theta with the horizontal. So she's pulling on some suitcase. It's a suitcase that has a handle, and she's pulling at an angle. Okay, so what does that look like? Well, maybe it's one of those roller, black. Maybe it's one of those roller type suitcases, wheels there. It's got some handle here, and she's pulling on that handle. All right, and it says that handle makes an angle theta with the horizontal. Okay, so horizontal is like right there. And so we know this angle in there is theta. Apparently, I don't know how big that is yet. The frictional force on the suitcase is 27 newtons, and Rachel exerts a 43 Newton force on the handle. Okay, that's important. All right, so this is what my picture looks like. This is kind of my physical picture. But alongside of that, I'm going to go ahead and put and I'll do this in blue. I'm going to make my free body diagram because it's talking about forces, and I want to see, what that looks like. Okay, so friction, if this is being pulled, if it's being pulled this way, then that means friction is going to be acting straight back. And that's the force of friction, which we know. I'm going to put that over here. Actually, I'll put it up here. Maybe. That's 27 newtons. And it tells us that Rachel exerts a handle of 43 newtons, and she's pulling on the handle this way. Notice it's a little longer because, that force applied is bigger. So my force applied, 43 newtons. And it asks us, what angle does the handle make with the horizontal? And what's the normal force exerted on the suitcase? Okay, so if I think about this, I still know there's a couple other forces. Gravity is pulling down. And I know that the ground is going to counteract some of that gravitational force, typically all of it. So I'm wondering why it says, why that's going to be hard to figure out. But then when I look at this, going back to that constant acceleration piece that we talked about, that means the net force is 0. And that's interesting. So that really means that friction has to be counteracted by something, and gravity has to be counteracting everything upward. So when I look at this, what I notice is that there's one force that's problematic, and that's this force that she's applying at 43 newtons, because it's not completely horizontal and it's not completely vertical. So I'm going to go ahead and I'm going to split this into components. See that it would really look like this. And so I'm going to, F-A-X and F-A-Y, just so I have some names there. And now I'm wondering, there's a whole bunch going on here, but I know the net force is 0, so really that helps me divide this into two different cases. I have my forces in my x direction. Makes me think of all the 2D problems we've done. And I have my forces in the y direction. And what I know when I look at my forces in the both directions, we have this net force equals 0. So that's interesting and that's important. So coming over to my f direction, or my x direction, I know that my net force is 0. But the only forces in that direction are my friction and my FAX. And that should still be 0 because my net force is 0, and that's for both directions. And then in my y direction, I know I have my gravity, and then I have my normal force, and then I have my force applied in the y direction. And again, that's got to be 0. And so, you know, I need to figure out this angle in here. And I think I don't have any information in this triangle other than the size of the force applied. So it'd be nice to have one of these other sides, you know, the FAX or FAY. Because, you know, in that triangle, and I'm going to just kind of blow up that triangle down here, just so we can see it a little bit more clearly. Drawn with orange. In that triangle, if I want more information, I need to know one of those sides. I know it's a 90-degree angle triangle. I know it's a right triangle, but I need one of those sides. And so what I'm going to ask is, which of those sides is easiest to find? And to me, FAX seems a little bit easiest because in my x direction over here, you know, there's just less information. And so, let's see what I know. Well, I know that force of friction is 27 newtons. Matter of fact, I'm going to call that negative 27 newtons. So I have negative 27 newtons plus FAX equals 0. Seems trivial to me. I know that FAX is got to be positive 27 newtons then to counteract that. And so if I use that information, I come over to my triangle, I know this is 27 newtons. And so I have some information on this triangle. And what I could do is, well, I could use trig to find that angle. I just need some space to do it. So I'm going to come over here. Okay. And I know, based on that triangle over there, it looks like a cosine ratio to me. You know, I have adjacent and hypotenuse. So cosine of theta equals 27 over 43. And so if I, you know, use my inverse cosine button on my calculator. Whoa, sorry. Calculator's flying everywhere. If I use my inverse cosine, I get 27 divided by 43. Inverse cosine, I get that theta is approximately 51.1 degrees. And so that's my answer to part A. Check. And then it says, part B, what's the normal force exerted on the suitcase? Well, if I come over here to the Fy, I know my force of gravity is going to be 28 times negative 9.8. You know, it's mass times acceleration. I know we have some normal force. And then Fay, I wish I knew that, because if I did, then I would only have one thing that I don't know in there. So really what I'm missing is that Fay piece. You know, and I've got some options. If I come over to this triangle here, I could use the Pythagorean theorem. Or if I stay at that triangle, I could use the angle I found to figure out that side. Basically, those seem to be my options, I think. So that's really, I'm going to need to use one of those. And if I do, I'm just going to go and use the Pythagorean theorem. I would get that other side is 33.47. so I know that's FAY 33.47, and all that's going to equal 0. And so then that is that's positive because she's pulling up, and gravity's negative, and my normal force has got to be positive. And so then I can do a whole bunch of little calculation stuff there. We're going to get negative 274.4 plus Fn plus 33.47 equals 0. And then if I go ahead and combine what I know, I really get negative 240.93 plus Fn equals 0. And so that means that Fn has got to be the opposite of that negative, because it's going to be 0, make it all 0. 240, and I'm going to round 1 newtons, which that's less than gravity, because gravity, is over here, right there. But it makes sense that this is less than gravity because she's pulling up a little bit, so it's kind of like the floor doesn't have to push up as much as it would have. She's pulling up, kind of saving the floor some of the job. So anyway, hope this helps. Have a great one.